Asalam-o-Alikum and welcome back. So for today topic is the sampling. This is the new chapter for the business statistics and mathematics class. So what is sampling? For any statistical investigation, it is often impracticable to analyze the whole population because of the restriction of time and money. To overcome the difficulties involved in dealing with the whole population, so we use the techniques of sampling. Sampling is defined as the process of selecting the sample from the population. So, statistic and sampling. So, what is a statistic? A statistic is a measure used to describe some characteristics of a sample, such as an arithmetic mean, a median, or a standard deviation of a sample. So, statistic is a random variable. Now, what is a parameter? So, a parameter is a measure used to describe some characteristics of a population. So, such as an arithmetic mean, a median, or a standard deviation of a population. The first one is statistic, it is about a random variable, and the second one is parameter, and it is about the population. So, write some formula so we will easily understand it with the help of this formula. Like when we measure number of item. So, for this, when we measure the sample size or the number of item for the statistic or sample. This is measures and sample. For sample, we use n, small n, and for the population parameter, we use capital N. So this is the main difference. This is about sample, and this is about parameter. The next is when we measure or when we take the mean, or we can say x bar. So for mean, we use x bar, which is equals to summation. Sorry for the inconvenience. So for x bar, we have the formula summation x by n, which is a small n. And for population or for parameter we use mean as mu, and it is equals to summation x by capital N. Summation x by capital N. This is for parameter. The next is about the standard deviation. So for standard deviation, we use formula for the statistic or sample as equals to square root summation x minus x bar का whole square. Summation x minus x bar whole square and divided by small n. So this is for sample. And for the parameter or the population, we use the standard deviation formula in this way. Sigma square root summation x minus mu whole square and divided by capital N. And the last one is about the variance. So for variance, we use s square. For variance, we have x square, and this is equals to summation x minus x bar whole square and divided by small n. So वेरिएंस का हम स्क्वायर रूट लेंगे तो वो स्टैंडर्ड डिवीजन हमारे पास आएगा. एंड व्हाट अबाउट द पैरामीटर और द population, we have the variance formula like sigma square equals to summation x minus x bar x minus mu. Mu means mean. Square whole square divided by capital N. So these are the main formula that we have to learn in the sampling chapter. That we measure the sample with the, when we use sample, so for the mean we have small n and x minus x bar. Summation x by small n is about mean for the sample, and for the population we have mu, which is divided by capital N. Similarly, for the this is the difference between the standard deviation and variance as well. Like for the standard deviation, we have square root in both of the formulas for the sample and for the parameter. And the last one is about variance. So for variance, we shift the square to the left side. So both the formulas are quite same. So what is estimator? This is the next concept. A statistic that is used for estimating a parameter is called an estimator. So estimate क्या होती है? An estimate is a value of estimator which is obtained from the observed sample. An estimate of a parameter may be expressed in two ways. So what are these two ways? Number one is a point estimate and the second one is an interval estimate. So what is point and interval estimate? A point estimate is a single number that is used to represent the estimate of the parameter. An interval estimate is a standard range, stated range, within which we may expect the parameter to lie. So we will discuss the next concept in this slide as well, like what is the standard error of x bar, we can say mean. So the standard deviation of the sampling distribution of the mean x bar, which is denoted by x bar, like we have a standard error. So for standard error of x bar, so for standard error of x bar, we will write it here standard, and error को हम e से present कर लेंगे. So standard error of x bar of x bar. So population size, we measure the population size with capital N, and population mean which is presented by mu, and the next is population variance is represented by sigma square, it is variance, and the population standard deviation is only sigma. Now the next is when we talk about the population size. So there is capital N and the sample size is small n. Population and sample. So this is about population and this is about the sample. This is about population. POP से हम present कर देंगे. So the next one is mean of the distribution of x bar. So we will write it or present it with the help of mu and small x bar. X bar. This is the mean of the distribution of x bar. The next one is variance of the distribution of x bar. So for variance we have sigma square x bar. And the last one is standard deviation of the distribution of x bar. So we have sigma x bar. Now there are some other formulas for the sampling with replacement and sampling without replacement. So इसको भी कर लेते हैं कि sampling विद रिप्लेसमेंट के लिए कौन से फार्मूलाज हम यूज करेंगे और विदाउट के लिए कौन से फार्मूलाज यूज करेंगे. सो फॉर सैम्पलिंग with replacement. Sampling with replacement and the next one is sampling without replacement. So उसको हम लिख लेंगे sampling without replacement. So यहाँ पर हम sampling with replacement के फार्मूलाज लिखेंगे. So mu x bar equals to mu. This is for sampling with replacement. The next is sampling without replacement. So the formula for this is mu x bar equals to mu. The next one is sigma square, and for sampling with replacement we have the population variance sigma square by small n, and for the sampling without replacement we have sigma square equals to sigma square by n into capital N minus small n and whole divided by capital N minus 1. So the next formula for the standard deviation, so sampling with replacement we have sigma x bar this is equals to sigma divided by square root n, and for the sampling without replacement we have sigma x bar and this is equals to sigma by square root n into capital N minus n, capital N minus small n divided by capital N minus 1. So in the next class we will try to solve an example by using the formulas.